right, well, welcome everyone to History 10W, Visualizing Evidence. Delighted that so many of you were able to come, especially since the registrar, in the registrar's infinite wisdom, had our class capped at an enrollment of 0. A wait list that was closed. So some of you may have tried to register earlier. We apologize for that, but in fact the registrar has now opened, and you can enroll if you're not already enrolled. Please do so. And as soon as we kind of get a sense of what our stable head count will be, then the sooner we do that, the sooner we know how many pizzas to order in future labs. So very important information. There's an incentive to sign up. So we're going to pass around a sign-up sheet here. If you can put your name and your ID, that will help us set up computers and other kinds of access that will be required for you to do the labs. So I'll introduce myself very briefly. I will also introduce my colleague Erik Steiner, who's teaching the class with me. But really, this is a class that's going to be taught by a whole bunch of experts and really creative people from across the Stanford University campus, and people we've been working with for years, and who have, we think, really exciting ideas about visualizing data and thinking about visualizing evidence in ways that we can think of using in the humanities and social sciences in particular, but I think across the board, whether you're in the sciences or the so-called softer side of campus, these principles and ideas about how to design the visualization of data, of evidence, are really important and can be helpful to you. So our concept in setting up this class was to offer a kind of entree, a way for people to come into our community, learn about the kinds of tools that we're using, learn about some of the ideas that we're developing around the visualization of evidence, and most critically, to offer an opportunity to kind of transition from a classroom setting where, don't worry, we're not going to be standing up here lecturing for 50 minutes every Wednesday. It's going to be very interactive. There's going to be a lot of discussion and conversation that takes place down here in this room, where we get to kind of play with our first of the big toys, the biggest of the toys, this wonderful screen here. But then we'll also be going upstairs to our lab. And so this is one of these odd kind of classes. I don't know how common it is in the humanities to have a lab, but we have a lab. And it's optional. So we want people to come to this class, and if you want to just come and have these conversations and learn about the kinds of things that are listed on the syllabus, that's fine. And you get 1 unit of credit for that. If you want to do the labs, you can get credit for doing the labs. And the labs will be directly after class on Wednesdays from 1:15-ish till about 3-ish. So one more thing that I want to offer you, and that is that you can choose, and we can talk about this in more detail later. I don't want to monopolize things with kind of bureaucratic matters at the beginning of class, but recognizing that it's a big commitment to take 8 Wednesdays, essentially starting next week, and commit from around noon all the way till 3. But you might be able to swing it 4 times over the quarter. So if you want to do 4 of the labs, and you're looking up here and you see specific things that you really want to learn about, specific tools that you want to experiment with, then you do those 4 labs. You can sign up for independent study credit with me. And so you can get more credit if you do the labs. If you do 4 of them, it'll be a unit. If you do all 8 of them, because you just love coming to our lab, then you can get 2 credits for that. So that's enough, I think, for kind of administrative matters. And the structure of the course, again, is we meet here, we have presentations and have discussion, talk about visualizing evidence using specific kinds of tools or certain kinds of concepts. Then we go up to the lab, those of you who want to do the lab, and work with these tools on the site. So you get to get your hands dirty, you get to get in there and use the tools and start to get an idea of what you could do with them in your own research or in your own kind of creative pursuits. My name is Zephyr Frank. I'm a professor of history. I've been here at Stanford now going on 13 years. And over time, I've just gotten more and more interested in questions of data visualization. I've been working with really big data sets, really complicated historical data sets, and visualizing the information in those data sets has become a really important part of my own research practice. And that's kind of how I got involved in the kind of work that we're going to be talking about in the class. The other way I got involved, and this is where I introduce Erik Steiner, is Erik and I, together with some other Stanford faculty and staff, founded the Spatial History Project back in 2007-08, and we've been working together now for over 5 years in that project, and that's why we have a lab upstairs. So we've developed a project, a large-scale, ongoing research lab in the humanities in this building. And Erik was the director, the original director of the lab, and he's our creative director to this day. Erik's background is in cartography and geography, and also information design. He's done award-winning work making atlases and interactive displays. He's been the president of the National Association of Cartographers. So he's one of the best in the business, if not the best in the country at this stuff. And so without further ado, I'm going to turn things over to Erik to kick us off today with the kind of description of what it is that we're getting into here. Erik, take it away.
Thanks, Zephyr. Well, welcome everybody, and I'm pleased to be here today. Although as Zephyr described, I work here at Stanford, and I am in the Spatial History Project upstairs. I actually live in Oregon, and I commute back and forth, but I'm only here once every month or a month and a half or so. So I'll be here for this session of the class, and then subsequent sessions I'll be joining you through some kind of form of FaceTime or Skype or something, but participating in the class. And I will be back for probably one or two of the other sessions. So I'm listed here for February 6th. I'll be leading that section, but otherwise I'll be helping Zephyr organizing the class and facilitating discussion. As Zephyr said, I'm coming to this from the background of a geographer and cartographer, and didn't have a lot of experience in research in history and the humanities before I joined this year. But it matched my interests really well, which is really about understanding how to synthesize information to make it understandable. Being able to take lots of data, whether it's qualitative or quantitative data, and organize it in a way that you can communicate and understand more deeply about that subject matter. And when I was approached by Zephyr and some of his colleagues in the history department about the possibility of developing a lab, I'm immediately excited because the opportunities that exist to bring together different disciplines and different technologies to bring to bear on some of these long-standing historical questions, I think are really interesting. So that's the standpoint that we're coming to this from. I'm interested in hearing from you. Are you? How many of you are history majors or getting degrees in the history field? And broadly in the humanities? Does that add anyone else? The other folks, what are the other points of origin for you?
Early studies, which I guess is humanities, I would say 60%. But I'm looking to do my honors thesis on medical photography.
Oh, good. Good.
I'm in the school for science.
Okay. So it's good to get some earth scientists here.
I'm in the civil engineering department.
Okay, and so, and those of you that, for everybody, how many of you have kind of programming experience, taking computer science classes, are interested in technology? Okay, so you've got about half the class has some interest in exposure there. And what about statistics? That's something that most people have taken statistics classes. Yeah. So this is kind of typical, you get this kind of mix of ideas and backgrounds, and this is kind of what in our little experiment of creating a lab, is trying to bring together these diverse skill sets and interests. This course, we aren't going to continue to just talk about our lab all the time. But this course is really about trying to bridge the gap between kind of these great inspiring visualizations that you've seen out on the web or exposed in your classes, and like how to do those visualizations. But we fall somewhere in between. We're not going to be able to offer a class that's really practical, that you'll be able to know all the software inside and out. So it's kind of resting in there between exposure to a lot of different technologies. We have network analysis with Zephyr, we have text mining, textual analysis, working with Google Refine and Fusion tables, online production of mapping systems, working with GIS tools, working with exploratory visualization software packages like Tableau. So there's a lot of different software and methods behind this. But most importantly, I think what this course will offer you is a reorientation on how to think about information. And even if you don't see yourself as a designer, to understand what what it means to design and what design thinking is and how you may be able to implement it. And at the very least, be exposed to different technologies so you can kind of put it in a box and say, okay, I know what that does. I'll never need to do that again in my life, hopefully. But you know enough about it. So the title of the course, Visualizing Evidence. This is a term that we've come up with. This is a course that's 3 years in the making. We've got a lot of different terms that we could have called this course, and is typically called, so I can get this started, typically called the different terminology that you see thrown out there: thematic mapping, information aesthetics, information design, data visualization, visual analytics, a lot of different terminology out there. Rather than trying to narrowly focus and say we are not this or that or the other thing, visualizing evidence is intended to be a broad brush stroke of all of these fields. So we will touch on mapping and cartography, we will touch on data visualization, some about statistical graphics, and so some of those will be covered throughout the whole course. But when you see this language thrown out there, some of these are fairly narrowly defined fields. It's not just kind of different ways of saying the same thing. Some things like visual analytics are primarily concerned with the cognitive process of understanding visuals and being able to make actionable decisions from visuals. Thematic mapping is more often thought of as certainly mostly spatial and geographic information being represented, but primarily for communication purposes rather than exploration or hypothesis generation. So it might behoove you to take a look, do searches on these terms and start to understand the breadth of these. So let's take a big step back before we really dive into this. I'm not an art history expert here at all, and so I'm calling on one of you who are an art history expert. Does anyone know what style of art this is on the right-hand side? Or even the artist that did either of these?
I think it's Cubism, but also blocks.
Yeah.
I don't know much more than that.
Do you know anything about Cubism?
I think it's the beginning of the 20th century, and it's just a different way to put together art instead of like fluid lines. It's more like kind of shapes.
Planes and blocks and things. So, like I said, I'm not an art historian, but I think this is a great starting point for us to begin to really think about what visualization is and what mapping in the broad sense really is. Beginning of the 20th century, as you said, Picasso and a few other painters started to explore this idea of trying to look at objects less as the reflection of the light that I see and the perfect realistic view of what that is. This, I'm not sure about this painting specifically, but the paintings that started coming out during this era were just absolutely trashed by the critics. The critics could not understand why somebody would take such a radical view on how something could be represented. this is Picasso, and so this is one of his earlier paintings, and this is one of his later paintings that was happening during this Cubist period. The heart of what Cubism really was rethinking what we considered to be the object of study, and rethinking our interpretation of it. In other words, our interpretation of light reflecting off an object that you see here, to kind of create this perfect image of what is in front of you, is only one form of understanding. It's only one way to really grasp what that object is. And so what Cubism really was is being able to, and there was a kind of obsession about form and structure, but beyond that, it was really about interpreting that subject from many different angles and perspectives. And so the idea was try to abstract, this is not the same one, but we might as well compare, abstract the different views of this woman, maybe from different vantage points or different mindsets, and into the basic form and structure. So this is really about identifying multiple forms, multiple perspectives, and abstracting it to the point that you're getting at something beyond just the perfect realism that was really, up until this point in the art world, primary. Why is this relevant to data visualization? Well, this was the first time this happened in painting. But 6,200 BC, we were already creating art that was representational, that was symbolic, that was abstracted. And so it was, this was found, there's some debate about this, whether or not it's actually a map. But this is sort of known as one of the earliest known maps. It's a 9-foot long cave painting depicting what they think is an urban area in Turkey. This is really the first image they've found that really shows a symbolic understanding and abstract understanding of space and spatial relations. So 6,200 BC. Fast forward to, no, this is not, sorry, this is the wrong title up here. This is actually about 1000 AD. I apologize for the error there. This was the first time that someone, so there's plenty more examples of maps in between there, but I wanted to bring in a graphic example. This is the first time, and the last time for some 500 years, that people actually thought about using temporal change and using lines to reflect that change. And so this is a graphic that depicts the paths of different planets over the course of a certain time period. It's not clear. And this is really the first time that idea of doing a linear graph came about. So this is about 1000 AD. Then we went through this kind of the medieval period and returning a little bit to the cartographic side of things. Again, there was an emphasis on realism. So this is symbolic in the sense that this is not a vantage point that the author ever saw when he produced this, but there was an emphasis on realism, kind of reflecting the actual objects, reflecting what was visible in the scene. So this is Constantinople, 1597. This was just sort of before the period of the Age of Enlightenment, the Age of Reason, where we really started to delineate things like analytical geometry and mathematics. And during this period, in the 1600s, people like Descartes and Pascal really advanced the theory and mathematics behind geometry and geometric representation. And so this is when you get the establishment of the Cartesian grid. This is where you start to understand possibilities of doing analytical geometry. So there's a lot of different, a lot of progress made during this period in terms of the theory of graphics. But there wasn't anything at this point that was really, at this point, a lot of the symbolic forms that we see today were not invented. And so, simple lines and letters on a page. This is fast forwarding to the 1700s. You can see the kind of advancement in the cartographic realm. This is a near perfect vertical view of this happens to be a map of Rome that was done in 1748. This is actually on screen here, it's about the size that it was originally printed. It was printed on 12 separate plates, and we've merged them together here. You can see some of the detail here. This is really to emphasize that this was really one of the first maps that had done a really serious degree of measurement. And this age was really about measurement and understanding the world through measurement. And so the cartographer actually engraved a description and methodology of how he did the map because it was so significant. Over to the left here, you can't see it, there's a compass rose, and he has one of these pointy cherubs pointing to the compass rose, like, see, we use the compass rose, aren't we awesome? So it's just really, he delineated the entire city in this way, with these chains. And just incidentally, if you compare this to a satellite image, I mean, it is phenomenal how well it matches up. You can see this is the area around the Vatican. You can see how all of the columns are delineated. So there's so much attention to that structural detail. So 1700s here. At this point, there hadn't been that many advances in the kind of graphical forms, graphical symbology. Again, there's still emphasis on looking at the world, looking at depicting space. This is William Playfair, who's commonly credited to be the inventor of statistical graphics. And this is Playfair's statistical breviary, and this was a book that he published in 1801. In that book, he really delineated a lot of different kinds of graphical forms that we're familiar today. So this is actually a great example that he brings in a lot of different kinds of graphical forms. He has proportional circles here showing different sizes of countries based on a statistical variable. He has a kind of inkling of a bar chart. He's got these different columns that go up. Bar charts started to appear in the late 1700s. He has some kind of trend lines here showing change over time. And here you can see he actually, first use of a pie chart. So these things that we really think are common are largely the result of William Playfair's work in the late 1700s and early 1800s. So as we moved into the 1800s, there was this kind of explosion of opportunity because you advanced in printing technologies and measurement technologies, and there was so much interest in trying to use some of these methodologies to reflect the data that were of interest to people. What were those data? There was a lot of interest in kind of social planning, urban planning, kind of government structures and how they implemented their ideas. And this largely came out of the work, largely came out of work of leaders in France who had a lot of ideas about how to structure their society, and they had a lot of quantification of their demographic data. And so this is one of the first uses of a choropleth map, where you color different areas with different shades, reflecting the data that are in the map. I think this is representing population. There's another one. I guess there was another one. It's looking at literacy. So imagine collecting data on literacy for the whole country and organizing it by these plots in the early 1800s. So there was a real advance in this area. If you read histories of information visualization, they'll talk about the late 1800s. That's really the time that everything kind of came together. You had a lot of technologies in place. You had a lot of interest and excitement about the possibilities behind it, and you had a lot of these data sets that were being collected. Edward Tufte, who is sort of one of these gurus of information design that has written 4 books on information design, which we'll talk about in class. He calls this the greatest graphic that was ever created. And in his mind, it's so great because it has so little ink on the page and so many data variables that are being reflected. So this is Napoleon's march to Moscow, and this is the size of his army. So it's moving across a literal space. There's a kind of latitude, longitude to it. It's being diminished over time. There's splintering groups that move off to other destinations. The brown is going towards Moscow, and then And then the black is the return. So you can see that shift. You see a qualitative shift there. Down here, he represents temperature over time. So he's really combining a lot of different data variables in a single graphic. This is around mid 1800s. This is a time when these kinds of techniques are really starting to flourish. And Menard, the author of this, has done several other images that are worth consulting. But all of this is really about communication. It's all about, this is what we know, this is the data we collected, and here it is. And advancing that agenda was the primary mode up until the late 1800s. It wasn't really until John Snow, an epidemiologist, started to think about collecting data and representing it spatially, using that information to come to some kind of conclusion, using it to investigate a question. So this is a map of London, and there was a cholera outbreak, several cholera outbreaks, and he went address by address, and he recorded how many people had been affected by cholera in those homes. And he very carefully annotated this on this is his final published image, but annotated it on a map image, and came to the conclusion that there was a clustering going on, that they didn't know the cause of the cholera outbreaks, the source of it, but he observed this clustering. And while mapping all of these data about cholera, he also noted where all the pumps were in the city. And so the combination of the pump layer and the distribution of cholera, made that instant connection and was able to identify that this pump may be a source for the cholera. They shut down the pump, they took off the pump handle, and the cholera epidemic subsided. So it was the first use where you saw an information graphic be about exploring a question, exploring an idea, rather than just simply communicating what is already known. This is a point where I want to make a solid distinction. This is what largely the last 30 years has been about in information visualization. It's the distinction between visual thinking and visual communication. So when we talk about visualization, we think about visualization as a lot of different things, but if we weren't in the context of a course, if I said visualize something, you would instantly think that's a mental process. That's something that you're doing internally. That's something you're imagining. That process of visualization in that sense is really what we talk about when we say visual thinking. Visual communication is everything else. It's putting things down on paper, sending them to somebody, for a publisher. It's drawing a note of how to get to your home for a party that night. It's all of those tools that you use, visual expressions that communicate a specific idea. The real question of the late 20th century was, how do we use the tools of visual communication to support visual thinking? So how can we use all these graphical techniques to then move forward this possibility of exploring new ideas and coming to new conclusions based on rich data sets? So as part of this image, I'll get back to the history, is to think about this continuum. And this is something to always kind of consult with yourself. Am I doing visual thinking? Am I doing visual communication? Kind of where am I at in this process, and how am I using these tools? So the far end of visual thinking is really about exploration. It's like, I have no idea what's going on. I just want to look at a bunch of things. I want to, try this data set, try that data set, search this, try to find some information. A lot of that can be done visually. Whether that's just on a whiteboard, whether that's collecting note cards in front of you, a lot of that takes advantage of our visual systems. Confirmation is kind of that next step of refinement. It's taking that and organizing that information, organizing it in a way that actually confirms more rigorously a hypothesis that you may have gotten from that initial step of exploration. Synthesis is when you actually, kind of put the pedal to the metal and you say, okay, am I doing the right rigorous statistical analysis? Have I got all of the right source data? Bring all that information together and refine it to the point that it's ready to present. And so in the presentation side, where you're really focusing on visual communication, you move from that private realm out into the public realm. So to summarize, we think about visual communication as presenting knowns. These are kind of some of the things that you might want to do.
Eric, just a quick question. We can make all these slides available to everyone in the class?
Yeah, I should know. We don't have it up running yet, but we will have a, hopefully by next week we'll have a website for the class. And so we'll be posting the slides and notes, and we'll hopefully have some video, and we'll try to collect all the resources together so that this can be archived. So these are kind of some of the things that we're very familiar with, using visuals to tell a story, to reveal a social network, show influence and causality. We do a lot of these kind of, tree diagrams or flow maps, just scratch paper, that kind of stuff, or illustrate consequences. Visual thinking has a lot of other opportunities. It's really about revealing unknowns, finding trends in systems, analyzing relationships, looking for structure in these large, chaotic, high-dimensional data sets. So there's a lot of things that you can kind of categorize on that visual thinking side of things. As I said, that's been largely the work of visualization in the last 30 years. If you look at the history of, here, Bob will get really excited if I draw this draw line here. All right. Are you watching, Bob? No, you're not watching. So if you look at the history of visualization forms, or symbolic forms, sorry, bear with me, just getting used to this. Let's zoom in here. If you look at the history of symbolic forms, and we talk about, say, this is 1000 when we first saw that graphic. You see kind of around, let's say that's 1500, that's 2000. Around this time, and as I showed, and around 1500, we started this advance in kind of variety of visual forms. And then it was really Playfair, this isn't working that well, really Playfair in the 1800s really pushed that forward. The invention of the bar chart, the line graph, the pie chart, that kind of thing. Then there was this period in the early 1900s where it pretty much plateaued, where you just there was not a lot of development, not a lot of new creative forms that were being put out. It was kind of a dead period. There was more advancing in calculators and technologies. Then there was a shift in you guys are really need to laugh out loud at me here.
I think that this is a great example.
Right.
The advances.
Advances in technology. It's amazing. So we'll just do the 1900s here. So we had this kind of period in the beginning where there's hardly any development of new ideas. Then in the 50s, with the quantitative revolution, advancement, as I was saying about computation, there was this huge new excitement about the possibilities. And so people generate all kinds of new ideas about what kinds of visual forms you could use. There was a development. John Tukey was a really forward thinker in scientific visualization, and he invented all kinds of new things, like parallel coordinate plots and all kinds of interesting new methodologies. And then since then, we've had this kind of gradual tapering off, where there really aren't any new ideas. Like people aren't coming up with new visual forms. Bar charts, proportional symbols. Here's a cartographic illustration, more bar charts. Network diagrams, that is something that's evolved really dramatically in the last 20 to 30 years. But largely, it's not about new forms. And then part of this is a challenge to you, is to say, wait a minute, everything's advancing so quickly, how can I contribute? There's so many opportunities here to generate new ideas about how we could reconstitute data into different visual forms. Largely what you see is development of tool sets that allow you to interact with existing visual forms. So these are examples of systems that really forward that kind of scientific visualization, exploratory visual thinking side of the discipline that allow you to make selections on one graph and have them highlight on the other, be able to display a network on a map and at the same time show statistical data in a more single-dimensional way. That kind of interaction has really advanced dramatically. But the ideas about what visual forms you could use, and I would argue even if you look back historically at some of the work that Playfair did, some of the other early designers, you could find some really neat ideas about how to reconstitute information in interesting visual ways. So, so what do we have now? What is kind of what's out there now? What are people doing currently? Bob, was that amazing? Did I do that? I just made a graph on the screen.
Everyone talent stuns me, Erik.
Watch this. No, there's no graph. So so what are people doing now? We're I mentioned up front, many of you may have come to this class thinking, oh, I really love all the graphics I see out there, and I'd like to be able to get some of that, or I'd like to be able to work on some of those. So we have a huge proliferation and democratization of creating information graphics. But largely, they're like this. We have this huge proliferation of Venn diagrams, as if Venn diagrams are the only possible visual form that you can use to explain it. No, don't get me wrong. There's some really creative ideas.
That's pretty powerful.
It's pretty awesome. Oops. I thought I had another in there. We'll show some more funnier ones later. But it's really high-dimensional data sets is really the big advance. Is that we've been able to collect and sense a lot more data than we've ever been able to do before. And so something like this is a map of science done by the folks at Los Alamos National Lab. They collected over 1 billion click streams, sequences of clicks on the web that people took through academic journal articles. And by examining these 1 billion click streams, they're able to generate a network diagram of all the different fields that were represented by those articles and a certain person's path. And they're calling this their map of science. So they're able to see which types of science are more related to one another, which ones are more on the periphery. Can you find history of the humanities, Zephyr?
I'm just fascinated by tourism being, in the same space with nutrition and neurology.
Language. So one of the challenges of these types of graphics, and you've seen a lot of these kinds of network diagrams, I'm sure. One of the big challenges with them is that it totally reorients in the same way that cubism does what we consider to be the foundation, the geography, the coordinate system, if you will, of these spaces. And so every new network diagram you create has a new space. It's a kind of a new cubic version of the reality. And so it's hard for people to interpret these diagrams now because it's hard to understand what it means for something to be in the upper left or the lower right. Or if you compared this to another diagram, what would that reveal? As opposed to a comparison to maps of the same space that have that literal geography, you have that direct comparison ability. So this is an example of of the work in science. There's lots of other ways that these high-dimensional, very rich data sets are being used. And again, back to the kind of overview and kind of big picture view of this class. This is really about what you consider to be evidence. What is your data set? What is the difference between data and information? And can you take data and turn it into information? And so this is an image that's a LiDAR data set, which is a very high resolution imagery that allows you to get very detailed, high-resolution topographic information. And this image is an image of the Willamette River in Oregon, and it's representing in this entire range of color is only 50 feet of variation in elevation, which most digital elevation models would not be able to detect any, one or two maybe differences in color variation. So by looking at these millions of data points in this LiDAR data set, he's able to reveal that the current channel of the Willamette River is not the only channel. All of this is land. People live in these spaces. There's towns in these spaces. But these are historic channels of the river, simply revealed by subtle variations in the landscape. Something that you couldn't see, something that would be invisible just by walking through that landscape or looking at Google Maps or seeing aerial images of the space. So thinking about how do you filter, how do you reveal through your lens what the evidence is in a data set, and how can you turn what appears to be just thousands of points of data into something that's very informative and allows you to really understand this hydrologic system. And I just wanted to mention this is by a friend of mine, Daniel Coe, who works at the Department of Geology and Mineral Industries in Oregon. Here's another example of kind of what you consider to be evidence. This is a study done by Erik Fisher, who was interested in where people took photographs. And he was interested in kind of comparing someone who knows a space versus someone who is just visiting a space. So his vision for this whole project, which he did for many cities, is locals versus tourists. And so what he examined, I'll come back to this image, what he examined was he scraped Flickr data, and he was able to get geographic coordinates for many, and I don't know the numbers on this, but he described it as if he pretty much tried to do all of Flickr and get everything in Flickr that had any geographic coordinates. And then he tagged that back to the original author of that photo, and then he traced whether or not that author had taken photos in that city previously in the intervening 30 days, or if he or she had taken pictures in another city for more than a 30-day period. And then he was able to distinguish what he thought might be a way to filter between locals and tourists. And then he connected the lines between each of the photographs if they were closer than 200 feet together. And so you create these visual clusters. So this is the result of that. So can you tell me which color is tourists and which color is locals?
That's true.
Right. So you see some really interesting patterns there with, who visits Oakland versus who visits Alcatraz. So this is a huge image, and he's done this, like I said, for a lot of different cities. It's really interesting to examine. You may be very familiar with certain cities, and it'd be very probably interesting and meaningful for you to look through his work. So Erik Fisher, he's got all these images on Flickr, of course.
Do you know what the other colors are? So the yellow and the green?
I think the yellow is undetermined, where he wasn't able to tell what, they were just highly traveled people, I guess. And then I'll just show a few more examples. We're about out of time. This is a similar kind of reflection of what evidence might be in our modern age. This is looking at Foursquare check-ins in Moscow and categorized by what she determined to be these broad brush categories. So she did this also this is Sarah Williams at MIT. She did this for several cities to look at the different patterns of where you might find outdoors activity versus kind of home activity. And she even started to look at the content and text of the check-in material to assess kind of mood and emotion that's happening in those spaces. And then she did a comparison of Foursquare versus Facebook. So she did this, huge, used a processing script, processing language script to scrape data from Foursquare and Facebook APIs, and was able to find places like this where you have a really strong distinction between people saying, oh, I went to Times Square, or I went, to Union Square, versus people that were checking in, more banal things. Whenever I walked my dog, or I, saw something on the street. So she was examining kind of the difference between Foursquare and Facebook use using these data sets. So again, it's really about the data sets. Something like this requires a lot of expertise in terms of technological scraping and processing of the data. But it's not necessarily for her. It wasn't about the insight. Was not about the fact that she had the skill set to do that. It was about understanding the possibility that she could do that comparison. And if there's anything that we want you guys to get out of this class, it's really about rethinking what you can contribute and what your ideas are that go beyond your technical skills. I think I will end there because we are just about out of time. But I hope that was a kind of a quick overview of the history of information design and showed you some kind of inspiring and creative examples that help you think forward what you might do in the class.
Okay, excellent. Thanks so much, Erik. So next up is lab. I know many of you are probably hungry. So today, unfortunately, we don't have food, but we will have food next week. We just had a little bit of difficulty getting things arranged. But those of you who are interested, how many here are interested in visiting the lab to